Hi, John.
Yeah, hi, I'm here. Good day, everyone, and welcome to day 2 of module 2 of the training program. If today is your first time here, my name is Dr. John Kwejan. I'm a professor at Howard University and then director of this training. A few things. Now, let me put my battery in. It says I'm losing power, so let me get that straight. Yeah, so again, you find the recordings in Slack. So check Slack for the link to the recordings of the sections for both last week and this week. You also find the material slides and then data set for practice. You find that in Varsity GitHub. At the end of this section, we'll post evaluation link, SurveyMonkey in the chat area here as well as in Slack, and then we entreat all of you to do the survey because your feedback actually helps us to make this better. So without any further ado, I will just hand over to Anas, who gave a very great presentation yesterday to continue for today's session. So Anas, it's all yours.
Thank you, John, and hi everyone. I'm happy to see a lot of people came back, so I didn't scare you off. Okay, so today we're going to probably do more of the coding, more of demoing the code and how you do data manipulation, data exploration, and data visualization. So less about the concepts and more of like how you do them. The idea is to give you these kind of like resources or tools that you can use as references, and you can go back and use them when you are doing some similar projects. That's the general idea. Although I still want to touch on certain concepts that I didn't get to touch on yesterday. So you guys see my my code, right?
Yes.
Yeah, okay, good. All right, the idea was to actually get through this yesterday, but I guess we didn't have time. So we're gonna keep continuing doing the work. What I did, I uploaded all the notebooks, and they're in a tutorial format, so you can actually read, understand the concepts, and execute the code. So we're
Can
yeah.
you please zoom in a little bit?
Yeah, sure. All right. Here we go. So all the solved notebooks are here, okay? And let me do this. I want to go back to this one. So we didn't get to finish the pandas essentials. I just want to touch back on the patient matrix. So if you weren't here, if you didn't join us yesterday, we talked about the patient matrix, and the patient matrix is a data frame that allows you to do your analysis, whether it's modeling, whether it's machine learning, whether it's regular survival analysis. You need to reach that level where you take your data, you bring it in a data frame that is ready for analysis. So, and that's why it's very important to reach that level where you code your data in a patient matrix. So what I will do, I will just go through one exercise here, one example, and we can then start working on the visualization. Okay, and you don't need to run this. I will just demo it, and for the visualization parts, you can follow along. Good. Okay, so it's it's this section. And if you have it, you can go back and try to understand it. But the idea here, if you have worked with Excel before, you pivot a table, right? You have a data that is in a long format and you're trying to pivot it to actually get your values and use sum, or you do some mean or some kind of aggregation, right? And this is very important, that it's at the core of turning your data that is long, like lots of visits or a lot of conditions for patients, into a matrix that you can use in your modeling, okay? This is a toy data. Okay, I'll have to run actually the pandas, right? We have to import it, run some of this stuff here. What else? I need to run this. Okay. Okay, going back here. What I'm doing here, again, I'm just creating a data frame out of this toy data. And you can see it creates your table here. And what I want to do is to pivot the table. So for that, you use the pivot table function, okay? And it's very handy. It's one of the functions to know in pandas. And what you specify the index, what I want as an index. So you can say here, I want to kind of like you say group by category, and then the columns of your table that you pivot, and the values, what you want to go inside these cells. And you can actually, like, there are, I'm not sure if, yeah, there are other, you can specify the aggregation function. So what I did here, I did Shift Tab, and that's how you get the help. And you can see what other parameters you can apply, okay? If I run this, basically the default one is sum. So it just sums the values over the index, which would be these categories, and then it gives us per month how much value, how much amount. So basically, whatever is that, is it in dollar or like an amount of money that was spent maybe on each category. So now that we looked at that, what if we want to do this for conditions, for a diagnosis, for example, right? So like I said, we have some data sitting in a GitHub repository, and now data can sit anywhere. You can actually upload your data locally upload it from Google Drive, upload it. So you just have to specify the right path. And for each type of like, for example, if it's sitting in FTP server, you have to actually use the right path to access that data. And the read CV is very, very intelligent in terms of like knowing where the data is and going and getting it, okay? So as we said, we had a path, and this is for the data that's sitting on GitHub. I'm getting a file called conditions.csv, which contains all the conditions of patients, okay? I still have to read it. And then if I run this, you can see here that there is a start and a stop for the condition, the date it was diagnosed. And if it's a chronic diagnosis, for example, if you see here, chronic diagnosis, you usually don't have an end date. Like if you have diabetes, there is no end date for diabetes, right? Because it's chronic. So there are differences between diseases, and it's good to know that idea, because if you're calculating differences between stop and start, then for certain chronic diseases, it doesn't really make sense, okay? And here we have the encounter ID. So this is probably the encounter when the diagnosis was made. So if you have an encounter table, you might go to the encounter table and have other information about the encounter with the patient. And the patient ID and the code. And I think this is a SNOMED code. So you can have multiple types of codes. You can have ICD codes, you can have OMAP codes. So there are multiple types of codes. And what I usually do, like I don't know them by heart. I mean, I can get a sense, for example, if the code is long, this is likely to be SNOMED. And I know ICD codes, how they're structured. But often I just type it here and say code. And then it tells me this is, where is it? Yeah, SNOMED code. And I know like what coding system that data is using, okay? All right. After that, we usually want to know how many diagnoses are in this table or just how many rows. And that tells you like the count function, if I apply it to the column. So I'm saying data frame, column, count, and that gives me the count. But if I want a distinct count, and this is like for those of you who come from SQL, this is select count, select distinct count, okay? You can specify it to a column, and this tells us the exact number of distinct codes that are diagnosed here. Okay, so the idea and the exercise I wanted to do here, can we compute a feat for each patient, have the patient as a row and have all their codes as columns, right? And the reason we want to reach this, because there is a concept also called one-hot encoding. And this is very important for machine learning because scikit-learn doesn't understand categorical variables. So if you give it female, male, or like categories of race, it won't understand that. And even if you code it as 1, 2, 3, 4, it will treat it as a continuous variable. So when you're dealing with categorical variables, you want all your categorical variables to be ones or zeros, right? Or some type of count and 0 if there's no count, right? So this is very essential because, and one trick I always tell people is when you have your matrix and before you fit your random forest, like you do fit xtrain, before you do that, look at your training. If it does have any string value or ID, then you're doing something wrong. Go back, make sure that all your categorical variables are one-hot encoded, or we call them dummy variables, okay? And that's how your model can run, but like it would just give you wrong results. So that's a very important thing to I want to stress and drive home. Okay, so if I run this, so this is a group by, I think we touched on this yesterday. What I'm doing here is grouping by patient and code. So let's go back here. So if you see the table here, I want to know how many codes or how many diagnoses per patient are in this table, right? So I group by and specify patient code, and the aggregation is count the code. And then I call it condition count. And usually if I do this, if I remove this and run this, all right, run, it uses the patient as index, and which is like you can, I mean, for visualization, it's good, right? Like if you want to like export this to an Excel or CSV file and make it look nice, that's good. But usually what we want to actually use the table later. So that's why we do reset index. So we remove the patient as index, and that assigns just a auto increments index. Okay, so let's make sure this, run it again and see if okay, so this is good. So what I'm doing here, I'm sorting by values and sorting values by condition count. I just want to see who are the patients that have the most diagnosis in that table, right? And the way you would do this, you you just apply like the function sort value to the data frame you created, and you can specify whether it's ascending or descending. So it's ascending, true or false. Okay. All right. Any questions so far before we move on to the pivot table?
Yeah, I have a question from
Yeah.
studies class. When I try to download the file, patient file to run, it does not work. It's showing error like at the beginning. From Cynthia folder to patient, yeah, that one, not before. At the beginning from previous class, when I try to download the file, the code I run, then this patient files from Cynthia folder to Cynthia file, then when I run it, it's showing error. But I know one of your
yeah.
Mhm.
It's so if you take a screenshot like and
I did it. I sent it in the morning. I did it. I sent this.
Oh, you did
in the morning, 6 o'clock.
Okay. I'm not sure. Did any of the TAs, Nana or?
I'm looking at it right now.
Okay.
Good. Thank you.
So what I think the issue might be like access to my GitHub. So if that's the issue,
Yeah.
I also uploaded everything to here.
And I didn't get it, that one too. Okay, module 2. I look at the module. Yeah, you mentioned.
So yeah. So here let me see. Let's try. Let's try view all. And what you would do, you can change this. I'm assuming this is public, right, Nana?
Yes, it's public.
Yeah, so if that doesn't work, you can just say try this.
Yeah, that's not this one. Okay, not this one.
And let's see if that works. Yeah, it did work. So if that didn't work, you can try to access the GitHub of the actual class. Okay.
Okay, I already sent this screenshot in the morning.
Okay. So we'll try to respond to you in Slack if that's the error.
Thank you.
Okay, yeah, of course.
Mm-hmm.
All right, moving on. So now we have the pivot function, and what we're doing, we're trying to see, and this is basically what we talked about yesterday, right? Assigning a count for each diagnosis. And so once I pivot the table, I give it the diagnosis grouped, which is the data frame I just created. I tell it, okay, use the patient as index, okay? And the columns that I want are the codes. So I'm telling it, please turn this into a column and put the value of that column as this. So just like pivoting, simple pivots in Excel. All right, so we run that, and you can see here that, okay, so what happens when a patient doesn't have a diagnosis, one of these diagnoses? For example, one patient has this diagnosis, which was sinusitis, but other patients might not have it, right? So once you index on the patient, you can see here, for example, that this patient never had this, because not all patients will have all diagnoses, right? So these patients here didn't have these 4 diagnosis, but he had this diagnosis here, okay? So what it did is created a matrix for us with as many columns as the conditions we had, and then it assigned values to each, which is the count of that diagnosis and how many times it appeared, which means how many times it appeared in our diagnosis table, okay? And what we usually do, we want to turn that value into zeros. Like, so an NA value is not easy to analyze. And also if you want to use a random forest, logistic regression, you need a 0 here. I'm talking mainly in Python, because for example, if you treat this in R, you can use this function called factor if you're coming from R, and factor can allow you to actually use the column, the categorical column as is in once you feed it to your linear models or any other models. So this is specific to Python, why we need to turn things like this way and assign zeros for the empty values. Okay, so what we do, again, we just fill NA 0. We saw this function yesterday, and then reset the index. And then here you have your patient matrix. Now, if you have another, like for example, you have another outcome. So these might be just this is your patient. These are the codes or the diagnosis that they have. And if I'm trying to predict mortality after a year, I can add that. Can everyone please mute? I think we're hearing some noise. So if I want to add another variable here, I can, right? Based on the patient. So I add a dependence variable, or the label, we call it in data science. And that's my label that I'm trying to predict. So it's a label maybe in the future. So you make sure that all these diagnoses happened in the past. And there is, for example, readmission, or there is death. I'm trying to predict mortality after a year. So I can use this matrix, feed it into random forest, and it will use the diagnosis that the patient had as predictors to whether they would die or not, right? And this is very simple, because eventually what you do more binning based on dates, you add medications, you add labs, and then you can do that prediction. And also one thing to note, when we say it's 0 here, it just means that it doesn't exist in the structured format in that table. However, if we go to the clinical notes, for example, that value might change. So that's why we always have to look at different databases, different formats, and make sure that our values here are as accurate as they can be. Okay, and yeah, this is just the shape. So this is a very important part of preparing your data for modeling, is to actually make sure that you have a concept in mind and you engineer that data in a format that can be used by your models. Okay, any questions about this?
So Anas, a quick question.
Yeah.
So assuming in most data, when there's an NA, it means the data is not available, and the user might want to exclude that data. But you're right, you have to know your data, right? In Ardo, you are indicating, in Python, you are indicating on line 25 that you want to replace your NA with 0. Do you have a rationale for that? I mean, is that you know your data, so you can replace it with 0. But in general, if it's NA, we try to exclude it, or we try to find if we can find data for that portion. And
correct,
go ahead.
correct. So what you're alluding to is imputation, right? So we don't always just replace a value with 0 or like some constant. We need to understand why that value is missing, and make sure that we replace it with the right value, right? And we will touch on that. It's one section I have in the exploration notebook. But in this case specifically, if you go back here, we didn't have any NAs, right? So this is an artifact, like the NAs that were generated here are an artifact of how we switched this table. So we switched it like this, and the patients that didn't have a diagnosis were assigned NA. So it's just what pivot table, when it doesn't find, for example, a diagnosis of diabetes for this patient, it will assign it NA. It just means that there is no diabetes for this patient, right? You get this, so it's slightly different. Like what you said is very important, and that's actually, you don't just replace, but here we're doing informed replacements because we know that we actually generated these NAs and we're just replacing it. Make sense?
Yes, thanks a lot. So primarily what you did was you turned the data from a long format to a wide format, and then,
Correct.
of course, it's like a hot ones.
Hot encoding. Yeah.
Yes. Okay, thanks a lot.
Yeah. And this is like there's I think one hot encoding from encoding I think from scikit-learn, and there is get dummies. So they both like can allow you to do something similar. So these are also functions that are very important to know. Okay, all right. We'll go now that we went through this. Cancel. Let's save this. Okay, finally, data visualization. All right. I really recommend if you haven't read this book, I really recommend you take a look at this book, Python Data Science Handbook, and they also have everything in a numeric way, so you can access all the content from Colab, and Colab is just basically the Google version of a notebook. If you're not familiar with Colab, you can actually, okay, think about notebooks as Word documents or the Microsoft Word on your local machine. The Google Colab is the Google Docs. So that's the kind of like the analogy. So you can actually like create a new notebook and x equal 3 and do the same things that we do in notebooks. So this is kind of like they give you a free version of a notebook. And what's really cool about this is I think they can allow you to get access to GPUs and TPUs, but not for long. So if you're running like 6 hours, 7 hours, they will lock you out and you will need the premium version. But for running just models and like if your computer is very slow, and I'm assuming at some point you won't have access to Codio, this is a really good resource to actually know, okay, as data scientist. So going back to this, like this is their version of Introduction to NumPy, data manipulation with pandas. So you can also like follow all these tutorials and learn about Matplotlib and also the machine learning part here. So this is a good book and good resource to have, okay? All right. Okay, Matplotlib. Matplotlib is the most used visualization library in Python. And the reason it's very widely used because it plays very well with different operating systems, and it visualizes very easily in different like Linux, Mac, and Windows. So that's one power of it, and it's also based on a very like the version of on MATLAB. So that's why it's also famous, because it just builds up on that. There's a hierarchy for a figure. So a figure contains axes, and can contain one or more, so multiple axes. And really, with the figure is just a box. It's just a container. But the actual figure, that like the intuition is that the axis is the actual figure. And then even the axis can have multiple subplots. So you can have a smaller figure here, smaller subplot, a smaller subplot here, okay? Few words here about the anatomy of a figure. So it's good to know what these components mean in your figure, because that's how you can actually customize the figure. Line plots, markers, so you can change the type of markers. These are called ticks, minor ticks, major ticks. These are called the spines. And yeah, basically the X label, Y label, and title and legend. So it's good to have that vocabulary and know how to access it and modify it. So if you want to modify your figure. Okay, so we import Matplotlib and PyPlot, and PyPlot is a sub package or of the matplotlib library, and we check what version we have here of matplotlib. And then we also will need NumPy. Okay. And this basically tells the notebook to plot instead. Usually what happens if you create a plot, matplotlib would, in Python, it would just like be in memory. So if you want to actually show it, you can run this to say, please show me my plot. So matplotlib inline. Okay, I think I opened the. So I want you guys to follow along. So we'll open the other one that's not solved. Yeah, so this is good. So if you want to follow along, I will give you a few minutes to at least do this first section here, and then I will demo the rest. Okay, so
Anas,
yeah,
I think you have to publish it for them to see it.
I think it's already published. This one?
The solved
No, this one.
No, I'm saying that the solved notebook folder is not showing on the student side.
Oh, it's not.
Yeah.
Okay. Does it show now?
Hold on, let me check again. No, it's still not showing. That's very strange. So I see data set export. Hold on. So there's the Codio backup, the data set folder, export folder, figures folder.
I don't see this one. No one does.
I don't see the solved one. No, yeah.
There's a publish here, right? Somewhere.
If you go back to the actual assignment and publish it from there. Yeah, to publish it, yeah, exactly.
It does show publish started, but it doesn't. Okay, publish completed.
Okay.
So, I mean, in any case, I don't think we're gonna need the solved versions today. If you have access to the unsolved version, that's what we need to work with.
Okay. Okay. Well, it's still not showing, but we can go ahead and just do it.
I
Just
also
continue.
Yeah, I also uploaded all of them to GitHub, so that's also one way of accessing them. But in any case, I don't think we're going to work with the solved versions, so it doesn't really matter at this point.
Okay.
Okay, let's go back here. Okay, so if you want to follow along and code, at least like one example, you want to open this one, data visualization. Okay. I can just send in chat, like if you are here, so we can start. So once you get here, you just want to run this one and up to here, and then we're going to try to plot the sine of x and cosine of x and both figures in the same, or the both lines functions in the same figure. All right, so I see some people saying here. Okay, we have few. I'll wait. I'll give it another 15 seconds. All right, perfect. Perfect. Okay, at least we have a core of people who are there. All right, so here what we want to do, we'll generate a random value, an x, and it's going to be a real value. And to do that, we're going to use this function from NumPy called line space. And what it does, it generates, you give it a range and you give it a number of values you want between that range, and it generates equidistant values between those two values. So the way it works, let's do x equal np dot linspace, and you can do this again, shift tab, and it tells you how the start, the stop, and the number of values between that. Okay, so I'll do 0. Well, let's generate 100 values between 0 and 10. Okay, all right, and then you would run this. Now to check the value of x, you just do x, and you can see here that there's a NumPy array starting from 0 to 10, and just equidistant values between 0 and 10. 100 values, right? You can change this to 10. It would just generate 10 values. This is very useful for random values that you want, like plot, or like initialize, for example, some model usually initialize values. You can just do this to initialize values. What is the Shift tab equivalent on Mac? It's actually Shift tab. I'm working on Mac. So you just like place your Shift and tab, and then that shows. Not sure if that works for me. Okay, now working. Good. All right, so to plot a figure, we'll just create a figure using, we'll call it fig, and then plt.figure. So we're just creating a figure, and there are two ways we're going to see it to create a figure. There's the object-oriented way, and there's the MATLAB version of it, which is you just create a figure and you're working on it, and then you can create another figure. And usually this one is better because you can actually go back and access that object and modify it like farther down your code. The other one is just like you're plotting whatever you need at that moment, but you might lose the state of that figure. So you might not be able to come back and update it. Okay, so what we're gonna do, use dot plot, and what this does, it takes, I think, x and y. Okay, let's do. So it takes arguments, plots y versus x as lines and or markers. So we're gonna give it an x, and then my y value, I will give it a sine of x. So there's a function, NumPy allows you to do a sine of x, and we can plot that. So this is basically two arrays of values. One is a function, a sine of x. It can be anything else. It can be some other real value, and you're just plotting x versus y. Okay. What I can do here, I can actually like modify the marker. So I think if I do this, it just changes the marker that I'm using. Can do O, and I think if you add here, like let's do this, R means plot it in red, use this marker. Okay. All right, let's copy this and do the same for cosine. And we'll just change this here and plot it in blue. Let's change the marker so we can, okay. No, not in this case. You don't need plot show. We're gonna see in other spots where you actually need plot show. I think it's usually like if I do plt dot like x label and then test, that still shows. Yeah, I'm not like 100% sure about that. Yeah. Okay, so moving on, what's you need to do if you want to plot the same figure, like both figures on the same plot, you'll do this. So you just add to your plot. So I'm just adding different lines to my plot. And that plots both of them at the same time. Okay. Everyone here? Like, all right, good. All right. Okay, I'll wait for 10 more seconds and then we can move on. All right. Moving on, you might want to, for example, you created this figure. You don't, I mean, you can do the save image as and save it, but maybe you're doing a loop, you're creating multiple figures, you're naming them per variable, giving them different names. So it's not feasible to just copy paste or like save your values. So there is a function plot, I think, or no, I think fig dot save, let me see. Yeah, save fig, and then you just specify the path, right? So let's go back here. So I have a folder here called figures, and we want to save that figure to this folder, right? Because we're working on a virtual machine, a VM, and we're working here in this environment. So the local space is here in the VM, and it will show here in the Codio. So I will do exports, and yeah, let's name it I don't have, okay, we have a question from Kiara. I don't have that line of code to write into. If you don't have like a space where to write, just click plus here and it can add for you a cell where you can write. Okay. All right. Okay, so let's call it my figure. My figure 1. And you can specify, I think you can specify lots of versions of exports. Like I think PNG, you can export in other formats like JPEG and other ones. And you click on this. And if we go back here and refresh maybe. Didn't show. Oh, it's going to export. It will be here. Okay, so good. Okay, I thought I did figures. If we change it, I'll do figures here, and then run it again. Go back here, refresh. Then I see it here, right? And then it opens up. So really, like what I was saying, you can automate a lot of this. Like if you're plotting multiple figures, multiple columns, you can just create loops and then go through the columns and then save your figures for to access them later. Okay. And to make sure that we actually like exported the value, you can actually upload it again from your local machine by using the image from IPython. All right. And these are the types of figures that that you can actually export to or use or manipulate using Matplotlib. Okay, can I go back to the syntax in line 12? Okay. You mean here? Okay. So here this is a function that gets an x and y, like a range, gets not an x and y, it gets a range. So you give it an interval and you say, give me, generate random numbers that are equidistant between these two ranges. So it's just a way for us to get a random variable that we can plot. It's not like really important. It's just like to illustrate the rest of the figures.
Yeah, I got an error there, and I think it's next line, variable x.
So when you run this, you get an error?
Yeah, I
This
got
one?
an error. Yeah.
What does it say?
Yeah, because I didn't have that next one. So I missed that line. So I'll just have to go back and correct that.
You mean here? The next one, just like.
Yeah, view the new variable x. I overlooked that one. So I'll go back and put that in. Thank you.
Mm-hmm. Okay. So as I said, there are two ways of creating your figures, and there's the MATLAB style, which is you plot and then you just add, like you create functions. So it's a functional way of creating your figures, and then there is the object-oriented way. And really, like I honestly like do both, or sometimes mix them up. It just really depends. But when you're, for example, trying to create a function and you're plotting multiple plots and looping, I usually like this one better because it creates a like an object in the memory, and you're actually able to go back and modify it. And here we have the matplotlib style, like the functional style. So we just right away start plt.figure, and that creates your plot in the memory. And you can then apply other functions, like you can say subplot. So we're creating here two subplots, and we're saying use two rows, one column, and the panel number, I think. So you can specify. I think the panel is the figure. If I pan, oh no. So the panel number is this. So the subplot where you actually want to access the value. So I'm saying subplot 1, 2, and I'm accessing this spot here. When I say 2 here, I'm accessing this. So if I want to plot, let's say, let's change the colors here. Red. So I'm plotting two figures or figures because the figure is this one, the whole thing. But the two subplots, so the sine of x and the cosine of x. And I'm saying kind of like plot in this coordinates, plot this function. And in the next one, plot this one. Okay?
So, Anas, could you please on 28, your first 211, could you, if what happens if you make it 221, then yeah, then let's see what happens in that way.
Let's do that. Yeah. So I'll have to do this then, right? Wait. Yeah. Right. So I created two columns. So I still have actually here two rows, but like ideally I can do this, right? And what it did, it created one row and two columns, and I'm plotting in each cell, let's call them cells, specific function or specific plot. So it's just a way of creating multiple plots in the subplots in your figure and assigning certain functions or specific visualization to those cells. So that's the idea.
So there's two. And I'm not to drag this on, but
Yeah,
could you make the second one 222? That will make it much more obvious. So here.
You mean here?
Yes, let's see what happens in that.
So the idea here, okay, so 222. So we're plotting over two panels, right? So that's why 222 plotted the first one, the second one here. So we're plotting in the, actually this one, we're plotting in the first column, the first row, the second column, and the panel number is 1. So we're still plotting in the second column, both of them. They're just split, and you're plotting over the panel. So if I plot over, if I do 2 here, it's the same one, right? Because it's plotted over it. So the idea is just to get a sense of those cells, and you're just trying to place your figure. For this style of plotting, you can get what's the active figure. So you can say plt.gcf, and it tells you which figure is active, and you can actually or current axis. So you're able to actually plot on top of that. But again, that's the challenge. If you are plotting multiple plots and you want to go back to one, you might not be able to. Now, this is more intuitive and it's more object oriented. So you create a number of plots, we say 2, and then I can access them with an index, right? And that's why the other one is a little bit tricky, but this one is actually you specify where you want to put your subplot. And you can actually go back, for example, here, we can use the clear function and clear one value. For example, let's clear the second one. We don't want to plot the cosine, we want to plot the tangent of x, okay? And then you can clear it and just plot something new here.
There's a question.
Yeah. So as I said, like figure and axis, the figure is your container. Think about it as a box. And the axis is where you would be applying, for example, adding a legend, it's the actual figure. So when you use the objects oriented, when you say plot figure, it creates for you an axis and the figure. Let's go back here. Where is it? It creates for you the axis and figure, and often like you're applying most of the actions or most of the operations are on your axis. Like I think there are a few like can say X label. Wait. Oh, actually, we have to, since we created to, we have to specify. Yeah, I'm not quite sure how we access that, but yeah, the general idea is that the axis is your actual figure, and you're applying the different operations on your axis. Okay, so the line plot, I think we went over this as an exercise. We can adjust line colors using the color parameter, or like doing it the way we were doing it. I think if we do just be like this, it will plot it. So you can actually specify color equal, or just basically say color equal blue. We can plot multiple figures or multiple plots on the same figure. So these are all different functions. np.sin x minus 0, minus 1, and we can assign different styles to the figure. You can use I think the hex codes. You can use grayscale. You can use just a short color code, or you can use the full color name. And you can edit the line style, so you can either do solid. Solid is also this. So if we do this, that's also solid. Or you can actually write the word solid. Dashed, dash dots, dotted. And this is the other way of doing it, like shorts for the codes above, as I said. And this is the other annotation. So using these type of keywords. Okay, so you can also adjust the X and Y limits of your plot. So I can plot my X np.sin of X, and then I want to actually adjust the limits. So you can just make this bigger. So you actually want, if you want to see like more space around one area or another. So we just add in here, if I'm saying, because the X value, our X value, there is a figure size, I think. So let me see if I have it here. Fig size. We're going to see it next. It's I think, let me see. Figure size. Yeah, there is a function. I'm not sure how. Let me see. Going back. PLT dot think plot. Let's do this. Yeah, there is a way. I'm just not sure which one. Scatter. Yeah, if you go through the documentation, there's a fig size. I think fig size equal, and you can specify the size by inch for a size of a figure. Yeah, exactly. You just have to tinker with the fig size. Not sure like if you actually have to do fig size here. Equal. Yep. So this is it. I think someone found it in the chat. So you do this, and that adjusts your figure. But okay, I think like we have to do it before, so it applies to the actual figure. All right, thank you, Quado. Yeah. So this is the parameter if you want to adjust it, and I think these are in inches, so you can just adjust the height and width. Okay. We can also label our x and y axes, so we can say plot and add a title. So you do plt.title, plt.xlabel, plt.ylabel, and you can specify with just write a string value for your x and y axis. And then if you want to see a legend, you just do plt.legend. And since we specified the label here, so this is another way of doing it. You're specifying the label here instead of doing plt.xlabel. We are specifying the label while we're plotting this. So plot.plt.plot, my x variable, my y variable, the marker and the color, and then I'm saying this is the label of x, right? Or the label of actually this is not the label of x. Scratch that. So this is the label of the line. So we're labeling the actual line plot. And again, I'm labeling the line plot of the cosine, calling it cosine of x, and that can help us once we do plt.legend to see these values here. Like if I do sine of x function, cosine of x function, I can actually get the modify it. There's also, I think, ways of specifying where you would want to put your legend. Yeah, so the location of your, what's the center lock. Okay, so we can do, I think, lock here and then do lower or upper right, for example. Let's see if that works. Yeah, so I think it takes only lowercase. So that's basically where you put your legend. You can put it in wherever you, or you can even like put it outside of your box. So this is the way to actually like what we just did was x label, plot x label, and that's where you can assign the label. For the object-oriented way that we went over, you'd say axis set x label. So that's why I was trying X label and it didn't work. This is actually the object-oriented way of doing it. Set X label, set Y label, and so on and so forth. And one good way about doing this in an object-oriented way is that once I have my axis, I can just keep giving the parameters here in one line. Set the X label equal X, set the Y label to sign of X, and then set the title to this. So instead of like writing them multiple times like this, you can have one row where you just set all these variables. If you change the marker to an O, you can get, I guess, a scatter plot. But we can also use, and there are different markers. So if you see, these are all the different types of markers that you can apply. And this is another function. Instead of like doing a line and specifying a marker, you can just scatter and these are like similar to the scatter plots we saw in the presentation yesterday. So we're just doing plt.scatter, and it's going to plot your X and Y variables. Okay, so bar plots are also very important, and this is interesting because in Matplotlib you need your X and Y, and in general when we're trying to plot like the bar plots, we're actually trying to plot a frequency, like how many of gender, how many females, how many males, how many of race A, race B. So there is a frequency. So the column that you have in your data frame, even though it might be like in a categorical format, so you have gender, female, male, you can't really plot it that way. Like you can't just use this. So you need an X and a Y. So I need to actually have another variable or another column that gives me the count. And that's what we usually do. We get the X variable, and then you do a counter. We're going to see it, and then we get the values. And this is just a simple way of plotting multiple variables over one figure. And you can see here that values around here, 6, I think 6 here, the index of, 6 and 6, and then they overlap. So if we see here, like we just plotted 1, 3, 5, 4, 5, 6, 7, and 9, but values around 6 and around, I think, to 4. So if you see here 4 kind of covered the value below it. So 4 is a 2, so we don't really see the 2 below. So that's one thing to be careful if you're overlaying multiple plots, is to make sure either you use different, like I think hues and or intensity of the color. Okay, histograms are also very important in terms of plotting real variables. Okay, and all you do is this is easy because it's one variable, and we're generating 10,000 random variables, right? You can see here what I'm doing. I'm just accessing 10 from 0 to 10, like the index, and seeing the random values that were generated. And then I'm plotting a histogram of that data. That's all you have to do. You can specify the bins. For example, this is a default bin. I'm not sure like what's the number, but eventually you can specify the bin. You can specify the intensity of the color, whether it's step filled, and the color you want, and if there's an edge or not. And you can plot multiple histograms on the same figure. Okay, so this is going back to visualization. This is not something that's, unless like you're plotting figures at a daily basis, you would probably plot a figure and then, you know, or two for your data exploration and then move on. So it is good to know, and it is good to get better at it and just like explore different libraries. There are other libraries that we're going to see, Seaborn and Pandas, which are easier and gives you like an easy, we call them wrappers around the matplotlib, and allow you to write one line of code to create your figure. Okay. All right. So we can take maybe 5 minutes break, and then we'll come back and start on the data exploration of this data set. Okay, so we'll come back at, let's try to come back at 12:20, okay?
Okay, thanks, Anas. Can we use this time to complete the survey? Stacy, let me see whether Stacy has posted it on. Stacy?
Was there a question? Sorry, I kind of cut off again.
I wanted to use the time to complete the survey.
Yeah, absolutely.
Yeah, it'll be better this way than to wait till the end. It takes about 2 minutes to do it.
Good afternoon, and thank you for attending Module 2. While we're on break right now, I would ask that you just either look at the chat or go to our Slack channel to complete our survey for Module 2. It would be greatly appreciated. It gives us feedback on our modules to know exactly what we need to work on 3 through 8 moving forward. Thank you. If you have any questions, please feel free to either message me on Slack or on the chat in WebEx. Thanks.
Nana or William, can you please verify that you see this section
Okay.
in this? So it's the third one, exploratory data analysis.
Yes, yes.
So
You mean on Codio, right? In Codio, right?
yeah, but when you click on it, I want to make sure that this is what you see, like the unsolved version. And then if you go down to 3, there is a table 1.
Okay, let's try that. So, slightly different. Can you scroll to the very top of your thing?
Scroll where?
Yeah, scroll to the top. Yeah, I want to see. Yeah, that looks like it. Yeah.
But can you please make sure it's empty here, and then you have this section here,
Okay,
number
table
3.
3. So table 3 only. Yeah, it's empty. Yeah, it's exactly what we want.
All right, perfect. Okay.
Okay, cool.
All right, good. So we'll try to get our hands on this complete exploratory data analysis. So for this exercise, I want you to open the third one, the third notebook, and we will try. I have few empty cells, and we will try to do some coding. Okay. I'll just keep an eye on the chat, and if you're here, just say here so we can move. Okay. All right, perfect. See you. All right, good. Okay, so this use case, we're going to use this a data set it's very famous in machine learning tutorials, and it's a diabetes data set, and the study population, it's all females over the age of 21 years old of Pima Indian heritage. And it's a data set that was collected by the National Institute of Diabetes and Digestive and Kidney Diseases. So really what we're going to try to do is use some of the pandas exploration or pandas tools we try to learn in notebook 1. We're going to also try to do some visualization. So we're going to try to use some matplotlib, but also I'm going to show you easier ways to plot using pandas visualization or Seaborn. And we're going to also talk about imputation. What William mentioned is how do we deal with some missing, for example, columns where the BMI is missing. What do we do at that point? Okay, and there are a few concepts of the way the data is missing. So we're going to talk about that. The link to the datasets on Kaggle is here. There's also a link to the UCI repository. And UCI repository is a good place for you to just view other datasets that you might want to learn from. Like these are very famous datasets: IRIS, the wine dataset, the heart disease dataset. There's the breast cancer Wisconsin dataset, and a lot of research papers have used these datasets. So it's very interesting, for example, to just go to one data set and then you see what columns, you get the data dictionary here, and then you can also see what papers came out of that, right? If you want like something that can interest you in your field, you can actually like see what they did or what type of analysis they did. Okay, so this is a good spot along with Kaggle for data sets. All right, going back here, let's run the pip install pandas. So make sure this runs. And next, what you'll do, we need to import pandas, and like we always do. And use the shorthand as PD. After that, we'll create a diabetes data frame, call it diabetes DF. And then again, pd.read CSV. So we saw this function, right? And then you specify, so this data set is uploaded here under datasets. So I'm going to access it by providing this path, okay? Okay, dataset. Diabetes.csv, okay? And there are other, okay, run this, okay. This is the error. No such file. Okay, data sets. We need a S here. Should say data sets. And then to view the top values, you just do head. And then head by default shows you the 5 top values. You can specify 10 here. Yeah. All right, good. So just say yes if you're done with this part. So you need to just install pandas, import it. Okay, Rodley, Michelle. Okay, good. All right. So moving on, we'll try to just do some extra exploration. So what's the shape of our data frame? You use the shape function. So it tells you that you have 768 rows, 9 columns. And if I want to access the columns, I will do dot columns. And these are attributes. We call it attributes of the data frame. And then we can see here that we have the pregnancies, the glucose, the blood pressure, skin thickness, insulin, BMI, diabetes, age, diabetes pedigree. So it's a pedigree function. It has to do with your family history, I think, of diabetes. Then you have the age and you have the outcome. And this is very interesting because this is the outcome is already in a format for you to be able to, like use it in machine learning. So you wouldn't really do a lot of preparation with this, except the missingness of the data. Here, the missingness of the data, again, need to see what to do with that. But this is our label or our dependence variable or the outcome that we're trying to predict. And these are the variables, and the data set is trying was collected to try and see if we can use certain variables like pregnancies and history of diabetes, BMI, insulin, glucose level, and all these lab values, and can we diagnose diabetes using these variables? That's the goal of the data set. All right, Azad, are we good? Explain line 5.
Yes, please.
Okay, so I think we've done this a few times. All what we're doing, we're importing pandas, and I'm saying read CSV. So we're using one of the functions that read the file and putting it in a data frame. And this is the path. This is the local path. So I'm reading from this folder here. Is that clear? What's exactly what's confusing you here?
A path. How do you get the path?
Okay, so a local path means when you put dot and then slash, that means that I'm here. So since we're working on a VM, so you might have notebook on your local machine. If you install it, then you will be trying to get the path of your local machine. You can just like try to access applications, users, and then find the folder where you have your. This is basically saying, okay, in this local folder, there is a folder called datasets, and under that folder, there is a file called diabetes. That's all what we're doing here.
So do I need to download this thing because I'm using virtual your thing? Do I need to download that just Python everything?
No. So this is all in a virtual machine. If you have if you have access to this, you'll be able to run this.
Yeah.
Now, if you want to do your own analysis later, you can download Jupyter Notebook, install it, Python, and then you can refer to folders on your local machine. Doing this. Okay.
Yeah. Thank you.
Okay, so we can use types by doing d types here. And you can see we already have all the variables in a format that we need. So integers, we have floats for the other variables that are floats. So these are floats, and these are integers, numbers of pregnancies. And the age is also interesting. The age is by year, so it's also an integer. Okay, so we can also use the describe function. What this does, it takes each column and provides you with the counts. Tells you like how many how many complete rows. So if you see here, we have 768 rows that are complete, which is what we had in number of rows, right? But for some other variables, we don't have all the rows complete. So that's the number here, and the count is changing. Okay, so pregnancies, age, and outcome, and the diabetes pedigree are mostly complete, and you have few that are mostly complete, and we have almost half of the data is missing for insulin. Okay. You can also do diabetes.info, and we can get the same information here, right? And it's kind of, this provides you kind of the types and the counts, but this also provides you with the mean, standard deviation, and the quartiles. So, okay. Sometimes we want to know the count, the breakdown of our class, or we call it the label. So I would do outcome, or let's use the other notation. So I'm accessing the column, and then I will use value counts. Value counts. And that gives me the number of my 0 class and the number of my diabetes class. So this is very interesting because you could see that the data is imbalanced. And this is an important thing if you're doing classification or in machine learning. You want to know what's the balance of your data set. So because if it's skewed in any to one class, then your models tend to predict all that class, like the majority class, and leave out the minority, because models are kind of like dumb. Like it's, if you tell me I have 90% of the class A, and I'm trying to predict whether it's A or B, I'll just predict everything as A, right? And that will give me an accuracy of almost 90%. But it is a naive model and doesn't serve you. So when you have imbalanced data sets, we do a lot of techniques of either balancing or choosing the right methodology or algorithms that are robust and that can be used for this type of imbalance. So that's why we always want to take a look at this, okay? Okay, Malik says he can't hear me. Can you guys hear me?
Yes.
Yeah, okay. So we have a question from Rodley. In this case, would you consider this as imbalanced? I would say it's slightly imbalanced. It's not like there is a cutoff, right? I've worked with data sets where mainly I worked with the data set of suicidal ideation. And you know, you're working with the 0.1%, or like people who actually who are suicidal or had a suicidal attempt. If you look at the database of EHR, that's almost like 1% of people or less, right? So that's extremely imbalanced, and that's why we need to do all these other techniques of, like we call it, nested cross validation. Make sure that when you're splitting and calculating the data, you're not biasing, or your splits. You might also want to do techniques like synthetic augmentation of your data. There's a technique called SMART, and when you do that, you want to make sure that when you're testing on your test data set, you keep the distribution. So that's one important thing. If you have an imbalanced data set, your training data set, it's okay to augment it. So I create more of the minority class to balance my data set, train the model, that's fine. But when I'm testing, you want to test on real distribution, because when you put your model in the wild, you want it to generate on unseen data, and the unseen data is the real distribution of the data. So that's one important thing to do. So it's really like a modeling choice, and you have to go through a few options and then see what's the best model and then evaluate after. Okay, so all right, moving on. This is, if you've done research, if you read biomedical research, table 1 is the most important table. That's why we call it table 1, because it's always table 1, and it gives you the study population of your study, or your clinical trial, or your observational study. So what we do with this, we usually generate baseline characteristics of our study population. And sometimes we also add some bivariate analysis. So you're doing some, like t-test, chi-square test, or some other non-parametric test if the data is not normal, and you're just seeing the distribution of over the two classes, right? So if you've done it in R, there's a famous package called Table 1, and there is an equivalent to that in Python. So this is the equivalent. Let's install it. Okay, and from table 1, import table 1. I think it's and then we call it my table, then table 1. Then we're gonna try to use our data set. So it's this data frame. Gonna copy the name, and columns. So what we want here, I think, what is a subset of columns. So I will specify this because let's see what this does before we move on. It's not showing the help. Anyway, let's take few of the columns. So I'm going to create another row here and do diabetesdf.column. And when we pass this, we need to specify which columns we want to use. So I can't add outcomes to this list. So that's why I'm doing this. I'm going to just select these up to here. And these will be the columns I'm interested in. Okay. And here I'll just say columns equal calls. And our group by column would be the outcome, right? So you specify this out. Let's see what this gives us. So it takes some time to run. Okay, oh, it did actually run. All right. So let's view the table. So anyone can tell me what could go wrong with this? Like what's what we need to actually do? So everything here is treated as a continuous variable. Everything is mean, and you have standard deviation.
Diabetes, it may be categorical, and also the pregnancy should be a categorical variable.
Yeah. So we have to like look at the documentation of table 1 and try to solve those issues, right? And some of them, like for example, we have to say categorical variables and are, for example, pregnancies and yeah, probably just pregnancies. But for this use case, I'll just consider it as continuous. Another issue is the tests. It's using t-tests. If we do p-value, it's true. I think it's p-val. So going back, I guess, so the documentation would be helpful. So it's just doing a t-test, and here you can see that it's very significant. You can adjust, if I remember right, you can, okay, here we go. Yeah, you can specify which variables are categorical. So you just provide them as a list. You can specify which ones are not normal. And that way you don't, let's say, I mean, there are multiple ways of testing normality, right? And there are functions in few packages that you can do that, or you can just plot the histogram, right? And do h.hist, well, diabetes.h.hist. And let's see, diabetes df. And you can see here, it's not really a normal variable, right? So I can go back here, say non-normal, and say specify to this h. And you can see here it's changed to quartiles, and I think it's used in non-parametric tests, maybe Kruskal-Wallis or Wilcoxon. Usually you can also do this to see which test was used, right? So this is really like just a way to view your data and generate that table 1 of your study population. And it's very important because we can look here that, for example, there is a significant difference in terms of glucose and the difference between diabetic patients and non-diabetic patients. And you can see here, the value, it's 75.3 versus 70. And then for the overall group, it's 72.4. That's the mean with a standard deviation of 12. And you can also see how many missing values you have per group, okay? And just to test this, we can also do categorical equal, and then you can specify. Like, for example, if we had gender here, it would be actually a good example. You do this, I think, then you run it. Okay, and then it would treat this as a categorical variable, and then give you a chi-square test. Can I explain the p-value? We're not doing. This is a univariate analysis, so it's kind of like you're doing hypothesis testing, but it's just to get an idea of your variables here and how they are different between the two groups or the two classes. And that's all it does. Like, basically, eventually, if you are doing some hypothesis testing and not doing machine learning, you might take this and then adjust for other variables, right? And then do some multivariate analysis and draw some conclusions. It's just a way to present your data and kind of see some patterns in your data, right? So it's not, we're not going down the road of doing multivariate analysis, adjusting for variables, but it just tells me, okay, well, glucose has a higher, is higher in patients with diabetes, and I can see it in my data. Now, it would be a red flag, for example, for me to see the other way, right? So just like few concepts that can validate your knowledge.
Here is
Okay,
also
so
showing, here is also showing glucose is lower among diabetics, like 110 versus 221. So how can you explain it? Because usually diabetes patients should have a higher glucose, but here it's showing 110 and non-diabetes 121.
Non-diabetes is 121. No. So here missing is this. It's just like not showing correctly. Overall is this. Non-diabetes is this. And diabetes is this.
Yeah, non-diabetes is 0, should be 0. Oh no, okay.
You got it? So diabetes is higher. It's just like the way it's showing, it's kind of like, yeah.
Okay, so this is for, okay, 0, 1, okay. Okay, good. I got it, thank you.
Yeah. Yeah, this is what I like about this, but table 1 can allow you to do all these parametric, non-parametric tests. It's very difficult to do other types of tests, right? But I really like, if you are doing just a basic analysis and it's for you, you can do this. If you are going to do a very rigorous analysis, you're probably better off not using table 1, because you can do other types of tests. You can test for normality and all of these other things, and then do the t-tests separately. But this is a great way to just like do very quick t-tests, chi-square tests, all of the other stuff. And I think also you can, not sure if you can test for outliers here.
How can you take this output? So how can you save this one and take it as a Word document? So how can you save it? Or like it says, you can save everything, but here.
Let's do this, I'll show you. So you do 2 CSV, and then you do this, and then let's call it exports. And so we're gonna try to export it here, and we'll call it table 1, okay? .csv. And if we go here, it should be here, table 1.csv. And it's like, if you open it in Excel, it will actually show it in the same format, right? Yeah, thank you, William. So like an overview of table 1 and what you can do and what you can't do. William just posted a link for that. All right, so we can move on now to dealing with missing data. So like we said, we have a lot of missing data, and it is always a decision. You have to understand your data. You have to understand how your data was collected, and understand how to impute it. So that's very important. For here, we're going to see the imputation part later, but I want us first to just explore the missingness. Okay. To do that, you can just do. Okay, so we can do diabetes df that is NA. And what this does, it just creates this indexing for each column, and it tells you true, it's missing here. True, it's missing here. It's false, it's not missing, right? And we can just do sum. And this would give us that number of missingness, right? Let's install this package. I like to use this package, missing.no. So install this package and let's import it. Import as MSO, MSNO. Okay, and let's import it. And I can give you guys 15 seconds or minutes to install this and get to here. Yeah, just type in the chat. If you're here, just type here, and so we can move on. All right, good, perfect. So what we're gonna do is use the bar. Perfect. Okay, so bar, and just give it our data frame. And this plots for you the missingness of your data. Okay. Now this is good. It just tells you numbers. It's basically just this plotted in nice graph. Cool, but it doesn't really tell me are some data missing with other data at the same time. So for that, we can actually do use other functions from this package. So I do matrix and apply it to my data frame and do this. And this is a visual for you to actually see the difference here. Like you can see that there are some clusters where the data is missing. And it's missing across. Like for example, insulin and maybe skin thickness tend to be missing together. All right. Now what you can do is create a correlation heat map. How correlated is the nullity of those variables, right? So we do msno.heatmap and then provide our data frame and run it. And that's what we just saw, right? There was some correlation, and here if the correlation is positive, it means that skin thickness and insulin tend to be missing together, right? So ideally you'd want like no missingness, and this is no missingness. And the values here show you like how missing and the correlation between those variables. So the closer to 1 means like all the time that skin thickness and insulin are missing together.
But it's 0.1. It's a 0.1, right? It's not like a high correlation. Like it's not a 0.98 or 0.68. It's not a 1. It's showing 0.1, right?
It's 0.7.
It's 0.7. You have to look at the intersection of skin thickness and insulin.
Correct, Malik. Yeah. So it's you have to find which column you're interested in and then the intersection, right? So 0.1 is with glucose. Okay, you can also use this and Dendogram, which is kind of like pure diabetes DF. Let's see what this gives us. And it's kind of clusters, like this is kind of like your phylogenetic tree, just clusters the variables that tend to be missing together. And the closer value to 0 means these ones are not, you have more complete data. And there's a cluster here. So when the data is missing from here, they're more likely to be missing together versus this cluster here. Okay. Moving on. Okay, so the way you would handle the missing data, you can do simple imputation, right? You can just put a constant and say, okay, I'm just gonna give it a random constant. And the reason that you might want to do that, there are, like for example, XGBoost or even neural nets can take a mask. So you're creating a mask, sometimes you see in the data -999. And that's really just is a mask for you to provide to your model to say, this cell is missing, treat it as a missing data. Now, not all the models actually have that ability. And you might want to, for example, if you have only few values, you might want to actually impute. So either you delete the data or you do omission. Either you replace the data, and there are few ways of doing that, or you can analyze and see, apply these methods, for example, that are not affected with missing data. So you can use the actual masks and do that. There are 3 types of missingness, and your data can be missing completely at random. So let's take, for example, weight. It's unlikely that someone who is overweight might have missing data, or like, so there's unlikely, it's the propensity or the pattern is unlikely to be due to the variable or other variables in the EHR, for example. So weight is, if it's missing, it's probably just missing at random. And there's the second one is missing at random, so not completely at random. And this is really, I think it's a bad name. It should say missing conditionally at random, which means that for some reason we have some missing data, and there is some variable that could explain that. So, for example, males, patients who are male are less likely to fill in a depression survey or patient health questionnaire. So, and females are more likely to actually fill up the survey. So what you do in that analysis, you are not going to just like drop or impute, or you might want to take in consideration that the male variable. So you look at your variable and you say, okay, what might be another variable that affects the missingness? And there is the missing not at random. And I usually think about smoking. So you sometimes unknown is because you're probably smoking and you don't want to disclose it. So that's one way. Also, sometimes if you're like the example, building up on the depression example, missing not at random means that being too depressed stopped you from filling up the data. All right. So at that point, what I do, like I just create another column, and it's kind of like a flag, and you call it smoking unknown, and then or like any other variable, like depression survey unknown, and you account for that variable in your model. So you use it, you create a new variable, you call it unknown, and you feed it into your model along with your other variables. Okay, is that clear? Any questions? Okay, so few functions here. You can drop NA, all of them. So we can just do this, and you can see here that we lost almost half of the data. So probably not a good way to start. So we want to keep our data, right? We can drop the columns that are all empty, and let's see, shape, that changed the numbers of columns. Let's see. Oh, it drops actually any columns that have any missing data. So it's not the column where you have all missing data, but columns that have any missing data will be dropped using this function if you specify the access as equal to 1. So let's see this. So dropping NA gives us 392. If we drop any column that has an empty value, so see here, insulin had some missing values, then it was dropped, and the skin thickness was dropped. So really at that point, it's a choice. You're like, okay, well, if this column has half, like 50% of missing data, maybe I could just drop it. But if it's a very important function or column, you might want to keep that information and impute it. This is just an illustration. Usually you don't want to do this. Like, this is what I was talking about. You can create a mask, for example, and replace all the values by that mask. So you can use it, for example, in your modeling later. You can impute using the mean, and this is how you would do it. You just say fill NA, and then you say fill it with the diabetes.mean. And let's see here what we're doing here. So this is the mean for each column. When I do diabetes.mean, it just gives me the mean for each column. And then I'm using that to fill the NA. So it's gonna know which column and just fill it with the mean. And here you can see that it filled the first 3 values that were missing for insulin with 155, which is the mean of insulin. And if I assign it back to a data frame, then we can see here, it should say data. Now we have 0 missing values, okay? Now, those were simple imputation techniques. You can use models or machine learning actually to, in a way, predict the value of each cell. And there's a package that's very known, called Fancy Impute. So it is a good package to learn, and it can allow you to do multiple imputation or KNN imputation. Yeah, the multiple imputation is this one, iterative. So it's a good package to know how to use. I'm using though scikit-learn, so we're gonna use scikit-learn and the KNN imputer, and what we're gonna do here is to use what KNN does. It uses the neighbors, the number of neighbors that you give it. So it looks at similar rows or similar values and around that missing value. And then it takes the mean of the values surrounding that point. So in a way, we're not just randomly giving a mean to that value, but we're using a model to be able to actually make our prediction or like impute our value in a better way. So the way you would import it, you just do sklearn.impute, import KNN imputer. what I'm doing here, I'm just creating the imputer. So you just say KNN imputer and you specify the number of neighbors meaning how many kind of like data points around that data point you want to impute. And we're going to create, usually you just do this. Let's run this. And then this would return back an array, a NumPy array. Now we kind of lose our columns, lose our understanding of the data. So what you want to do is maybe for purposes of like either like keeping your data, visualizing your data, you want to keep the columns, and that's what I'm doing here. I'm imputing, but feeding back that NumPy array and creating a data frame. So I'm creating a data frame out of the imputation. Okay. What we can do is this, like to make it clear, data equal, and that's our imputed data, and I can say data equals, and diabetes.df is the columns of our data frame. And you can see here that the first three of the insulin are not anymore imputed by 155, the mean. They're actually imputed given other values in similar to this value. Like, because if I have high glucose, high blood pressure, probably I'll have higher insulin too, right? So you're doing an informed imputation. And to test that, we usually do density plots. And what I'm doing here, this is the insulin that we imputed. This is actually the insulin value of the column that we just dropped all the values. So we're keeping only the values that are complete. So we call it complete case. This is the diabetes KNN, which is this one we just created. And then this is the one where we imputed by the mean. And what we want to do is to see if we changed the density of the variable, okay? I think okay, and you can see here that the mean imputation completely changes our the density of the variable. However, the complete case and the KNN imputation actually approximates very well the actual variable. So that's one way to actually test whether you've done the correct imputation. Other ways are you can just like run your models. For example, you run the regressions or you run the classification and you see what you get. You can see here that the original count was 394, the KNN now is 768. So we imputed all the variables. And then you can see here that the standard deviation changed, the mean didn't change much, right? So you can see it here, the mean kind of shifted to the right, which is the okay, any questions on this?
Yeah, Anas, I think that's very good. I mean, especially if for some of us whose statistics are a little weak, it shows clearly that visual is the best way to go. I mean, once you do something, you want to look at it and see the effect. And this is one good way of doing it. So now, besides the density, making sure that your imputation doesn't distort the density of the underlying distribution, what else could you have done? I mean, besides looking at density?
I mean, honestly, like you could look at these descriptive statistics, or you could actually run some model, like basic model. You can run a logistic regression, and you see sometimes people look at the actual variables, like the actual in the equation. You look at how the equation was created, and you compare both. So sometimes you keep doing the modeling, and you just see whether that gave you better results or not, given, like, for example, whatever metrics you're interested in, or you do your regression and you see if, like, your regression is too different from the complete case.
Yeah, thanks a lot.
All right, so we have 20 minutes left. Okay, so okay, let's try to go through this. I think we've covered a lot of filtering and describe, so I'll just show you what we're going to try to do here is an age group and grouping. And it's sometimes good to turn your continuous variable into a group if you have some basic understanding of, like, variables. Like, for example, people over a certain age, like, for example, people who are below the age of 30 might be more likely to use opioids, let's say, or like to develop an opioid dependency. Now, models can actually take care of that, even if you give them the age as continuous variable. But just sometimes for visualization, you might want to do some grouping by age or some grouping by BMI. But eventually, if you have age, you just use it as a continuous variable in your modeling. We don't usually group it. And plot this, and then we can use this function called cut. I'm just gonna copy paste it for you guys here and explain it. Import numpy as np. And what we did here is we're trying to group the age by group and create a column, and you can use a function called pd.cut. You provided the column you want to cut, and then you provided the bins that you want. So since our data starts from 21 years old, you can say from 21 to 45, that's my first bin, 45 to 65, that's my other bin, and above 65. And you just give it the labels of interest. And you can say right equal false, meaning don't include the right value of the interval. And that's what we did here. So we have this, and then you can also just do value counts, and then you can see how many people per group you have. We also have different ways of filtering the data. I can do, like, use the age group and say equal. You can just use the age column and use the continuous variable. You can do or and. So, for example, I'm interested in only people who are over 65, below 45. And that can give you that, and you can see here it's the same age group. So it's just like few ways of filtering the data. We can use, okay, so this is a function. Usually what you do, you do BMI group def, and what we're gonna see here is the map function, and that's what I want to illustrate. So I'll just copy paste the BMI groups for you and explain it. So what we're doing here, we're creating a function that takes in a variable x, and if x is below 18.5, I'm going to return unhealthy low. If x is in a range of 18 to 25, healthy, and so on and so forth. And this is your function, right? And what we want to do is to apply it to this column. So it's kind of like similar to what we did with the age. So we can do it with cut, but this is another way of doing it. And the way you would do it, you would apply. So this is how it works. You do dot map. So I take my column dot map and then apply the function of interest, right? So if I do this, this will return a grouping, and it's a series. And if I want to save it, I'll do create a column in my diabetes data frame and call it BMI category. Now to access it, I can do this. That value counts. And then run it. Okay. All right, so this is now we're at data visualization. So there are a few ways of visualizing your plots. Seaborn is one good package to learn. So you just say count plot, and that provides you with the count of your variable. So what we did here is provide the X variable or the column, and we're providing the data set. You can do this with matplotlib, and if you remember, we need an X and Y variable, and this is what I was talking about, the frequency, because we have one column and we don't have an Y variable, so we're using a counter, and I'm counting the numbers. Let's look at counter. I'm counting the numbers of that column, okay? Healthy, so it just generates a dictionary for you with numbers of the counter. And then I'm using plt.bar and giving it the X value and the Y value. This is what we were doing, like X, sign of X. So this is the values that we have. And then that plots for us the variable. There's another way is to use pandas visualization. So I say, you often just do dot plot dot bar, and then you need to give it some type of count. So that's another way. We can use dot plot. So this is also still pandas visualization. So it's your data frame dot plot, and you can specify the kind of plot. So I'm using scatter and then providing the X and Y and a title. And that plots our age versus BMI scatter plot. It's also helpful to plot the box plots, and pandas visualization has this function called dot box plot. So what you do is provide the one variable that's continuous, one variable that's categorical, and you say by outcome. You can also just add, I think you can do this. Let me see if this works. And this would plot multiple ones for you. And as we see here, there are like multiple outliers. So you can do other tests for like Taki tests to see if you have outliers and how you deal with them. Do you drop them? So it's all decisions in your data exploration. For here, I'm going to use this box plot. So box plot from Seaborn is a great way to visualize this. So if you see here, it's not really nice or pretty, but here you can do this. And let me remove this. So you just have to provide the X, the Y from your data frame and your data frame. That's all you have to do. And you can then plot it. So it's the outcome is diabetes, the glucose is higher compared to non-diabetes, right? Now I can also add the notch, which provides you with the 95% confidence interval. So if these two don't overlap, just means that the true median is higher for this compared to this. Kind of like a visual to tell you that there is some significant difference between the two groups. And what I do here, I just plot multiple values, multiple continuous values. So I'm saying, calling them features or independent variables. You can then enumerate over your features and create multiple figures, right? So this is all I have to do. Like, for example, if I want BMI, I'll just do this. And that shows me the BMI, right? But if I want multiple and I don't want to be plotting them at the same time, and maybe I need here I can save the figure to a folder, and I have like 100 variables. Maybe I want to do a loop and visualize the loop. Now, all what we're doing here, if you remember, we have a subplot. So I'm getting the number of rows here, which is the length of the features divided by 2, and getting the ceiling of that, which will be 3. So I have 5 features, and I'm trying to draw 3 rows. And here I'm using the fig size for the figure size, and I'm enumerating and plotting in each spot. So I'm plotting the very first one, BMI here, plotting then for the second one, pregnancies, I'm plotting it here, and then so on and so forth. And then this means 2 columns. So we have 2 columns. We can also use the scatter matrix, and this is what we saw yesterday. I think it takes some time to run. And this plots all your variables, well, mainly all your continuous variables against each other. Because like you don't see here the age group and the BMI group that we added. And it just shows you the difference, for example. See here glucose with insulin. And you can see here that this kind of like linear trend, and then the difference when you color it. So here we're using a color, which is creating a map for that color as dictionary and providing it for the scatter matrix. That's what we're doing here. Okay, I'll try to go through this quickly. We can also do correlations. So we can specify 2 columns of interest and run this dot correlate, and it can give us the correlation value. Okay. Now, if we want to actually do the correlation on the whole data frame, what you would do is this. You can specify what type of method you want to use, Kendall, Spearman, or Pearson. They're all available, and you can then run this. And then what I'm doing here, I'm just specifying a background for my data frame. So it's just turning back your data frame and presenting the correlations between each pair of your data frame. So pregnancies pregnancies, of course, the correlation would be 1 along the diagonal, but you can see that we have some high correlations between BMI and skin thickness. So these are like some kind of like trends or ideas that you can explore given some high correlation. We can also plot this, which is nicer, just gives you the correlation plot, but in a kind of like a nicer, cleaner way. So here, if you see this, it's kind of like repeated across this table. So this is the same thing as this, right? So what we want is to plot the actual triangle. Okay, I think we're gonna end with this, and then I will open it for questions. This is one way of generating your data exploration report. So if you run this, takes some time. I think I have it generated, so we don't have to wait. And then we click on it. Let me see, download. Okay, perfect. So that's one library, and all it does. Let's go back to the code before getting here. I'm just giving it the data set of interest, and then telling it, can you do a profiling of my data set and provide me with a report? That's all I did. And this, it's so powerful. It generates for you this nice report with all the dataset statistics, the number of observations, how many missing cells, duplicate rows. So it does that for you too. And the size of that. Some warnings here. It tells you that the columns of interest have some missing values here. And this one has some zero values, like 14.5 were not pregnant. And what's cool about this, it gives you all the distribution here. It gives you the missingness, it gives you the mean, minimum, maximum. And then you can do this and then see your histograms, your common values, you see your extreme values. So it does this for actually all the variables, and it tells you kind of like this is one of the variables that you might want to deal with, right? And here you have your interactions between the two variables. So these are the scatter plots like that we were trying to do. Like your age, BMI, I think we did BMI age, so it's here. Then you have the correlations. So we've seen Pearson, but you can do, you can view the correlations, the other types of methods that generate correlations. This is our figure. We've seen it, right? The missingness. And then the other figure, like how that can tell you if some of the values are missing together. The heat map and the Dendogram. Plot some first rows of your data. You can see the missingness here and the last rows. So there are, and this is what's powerful about Python. You'll end up with there are ways of doing the same thing in different ways, and there are really great packages that you can learn and that can make your life as a data scientist easy. So I just want to say one last thing. I think we didn't touch on the COVID data visualization. Please feel free to go through it, and you have the solved version here, and it helps you plot the figure, like the growth figures that we've all seen in the New York Times. So it just helps you plot that and plot some interactive versions of that. So you can go through that, and these are the semi-log plots for that, and plotting the deaths, plotting here the deaths over 25. So just if you have time, you can go through it and just like post in the Slack, and I'm happy to answer any questions.
Yeah, so before you ask questions, let me do a few homework here, then I'll give the floor back to Anas to answer your questions. So first, please complete the evaluation. This is posted here in the chat area. I think you'll find that also in Slack. As I said at the beginning, your evaluations are very important to us, the planners, to make things better for all of us. The TAs are still available for assistance if you need any questions, or if you need any assistance, just post a request in Slack, and then one of the TAs will be happy to assist you with that. Module 3 is in 2 weeks. Module 3 is not next week. That will be in 2 weeks, and that will cover a lot of the statistics that Anas has given us some overview. So we'll do more statistics next week. No, not next week, in 2 weeks. So in the interim, as you are waiting for module 3, there are some hands-on that you can practice on your own with Python, and then to practice some of the concepts that you learned in module 2 as well as module 1. And again, if you need assistance, make a request in Slack, and then the TAs will assist you with that. So we are very grateful to Anas. I myself am a Python novice, and I've learned a lot, and I'm sure many of you who are novices have also learned a lot in Python from last week and then this week. So thank you so much, Anas, for another great presentation. So now you can ask your questions if Anas has a few minutes to.
Yeah, sure. I have a few minutes. Yeah, I can stay.
All right. So any questions, you can ask it or you can post that in the chat area.
Let me
So
see.
the solve notebook folder, we will put it on GitHub, but I'm working on why it's not showing up in Codio, and we'll fix that also. So you have the solve notebook right now in GitHub, and we'll have it also in the Codio shortly after the class. Okay, so you can look back in Codio and check the folder out. Thank you.
Yeah, so the same one is completed in GitHub, and I just posted the link. I'll post it again. But yeah, I guess eventually Nana will work on that.
Yeah, and so a quick question, if anyone doesn't have any questions. So now, does this profiling, does it generate a code? Because for most Python programmers, looking at the output is very cool. It gives you an idea of what can be done. But it will also be nice if I can see the code behind the profile. I mean, like when I look at the histogram, what is the code that drives the histogram? When I look at the missing value,
yeah, good. Yeah, and that's why I actually went through the code. So that's how you would do it by yourself. But like if you go to the package itself, like on GitHub, you'll see they have a GitHub page, and you'll see how they are coding each piece of that. So it's just basically a function and the wrapper, and they're feeding it a data frame, and the columns, and then it's running all that code in an automated way. So you don't have to do it on your own. But yeah, like if for a learning purpose, like you might want to go to GitHub and learn it, or like just like go through the codes that we've done.
Okay, cool. Thanks a lot. Great, great.
Thanks, William. We have a question from Malik. What does the enumerates function do? So when you enumerate over a dictionary, for example, you have you can say for index, comma, or like for key, comma, value, enumerate over my dictionary. And what it does, it just goes over your dictionary one by one, and then give you access to the key and the value, right? So that's all it does, the enumerate function. So it's one way to enumerate or like to loop over a dictionary.
Anas, can you hear me? This is Helena Thompson.
Hi.
Hi. I'm new to Python, first of all, and I was in biomedical informatics, so I just finished that this year. However, we didn't do Python, we did SAS and MATLAB.
Yeah.
What I'm noticing here in Python, as far as your analysis and your outcomes, is much easier to follow compared to what I've learned. I came out of the background, hospital background, where I pretty much dealt more with managing HL7 messages. My question to you, in your career in biomedical informatics, were you always Python, or did you do something else, or how did you pretty much deal with the real world as far as the Python?
That's a very, very, very good question. Actually, so I started as a software engineer. So I've done lots of Java, Android, I've done SQL. So that's what I did before. And then I fell into the biomedical informatics field, and I did a master's in systems medicine. and we used a lot of R. So, and you'll find that a lot of statistics and lots of packages in biomedical field are actually in R. And what I did, as I started like doing also machine learning, I found that the packages in R are not perfect, like especially if you're trying to run like some deep learning using TensorFlow, it's very clunky, it doesn't install correctly. Then I always done Python for data manipulation. Then I was like, okay, I'll focus on Python. So I would say focus on one. I mean, SAS is great for example, doing statistical analysis. R is great for that too. Python is king in data manipulation. So if you want to manipulate data, you can do it in R. There's tidyverse. But eventually, if you want one-stop shop, and I'm sounding like I'm praising or like I work with Python Foundation, but like I really recommend Python. So learn Python and force yourself. For example, I was forcing myself to try and find how to do a t-test in Python versus doing it in R, because it's much easier in R. But like if you start learning these steps in Python, you'll build up that capacity.
I see. And
Yeah.
one more question. When you're in the industry, because I noticed that you talked about Seaborn and Matplot, do you choose what or how you want to derive your conclusion, or is it already there for you from the company itself, or how does that work?
It really depends. I mean, also again, we're talking about data visualization for presentation and data visualization for exploration. For exploratory analysis, you're free to do whatever you want, right? You can generate your report, and the idea is to just generate a PDF. That's the end goal. You're exploring data, and this is some information I have. So I'm not presenting the data, all right? But if you're presenting the data, then that's a different idea. Like you might want to learn Plotly, you might want to learn Tableau, like what's the other one? BI, I think the Microsoft one, forgot the name. So there are different ways of visualizing the data for presentation. But if you're doing just exploration, you can choose Seaborn, you can choose whatever you need. So it really depends what's the use case.
Thank you.
Yeah, of course. Do we need a computer science background to learn Python? I don't think so. I mean, you do at a certain extent if you want to really understand the like the scientific kind of like NumPy, for example, the indexing, all of that. At some point, you might want to dig deeper, but I don't think it's needed. A lot of people use Python without a background in computer science, and there are like snippets of code. Even if you don't really 100% actually understand that code, like you can like use a function that does this, and you just copy paste that function. So more of an integration of code than actually like it's not like 100%, unless like you are coding for a company and you're building packages, then probably at that point you need to be more efficient. Can you suggest resources to plot chi-square and RNA-seq data in Python instead of the R ones? I think heat maps would work. I'm not really sure. Like I've never done RNA-seq in Python. Yeah, like honestly, like, yeah, I'm not really familiar, but you probably, if you have your data, you might be able to use the heat map in Seaborn to plot that data. What were the two presentation programs? So I meant Tableau. Tableau is like a one-stop shop for visualization, to create dashboards, to create reports. So you don't really code, you just like drag and drop. There is Data Studio from Google. That's also another good visualization. Plotly is more like Seaborn, so it's Python, but they also allow you. They have this dashboard in kind of cloud version where you can actually publish your dashboards if you want to show them in a web application format. Yeah, the Microsoft one is Power BI. Yeah. So really at the end of the day, if you're doing modeling, you're probably going to just need to do some visuals to kind of explain something, see your results. Like, for example, even I would say this, even after you build a model, you can plot your AO-ROC curve. And the curve itself is important to know how it's shaped. You can have the same value of two models performing at like 80% AUC ROC, but they might be different. So plotting the curve is also important to choose which model. So it's really like at the core, you're just like going throughout your data science lifecycle journey, and you're plotting, exploring as you go. So the idea is not really like creating nice visuals, but more like the exploration and analysis. Any other questions? Let me go through the chat and see.
So that's a quick question. So
Yeah.
what do you think about the data science package? I mean, that's the equivalent of tidyverse in R. I just stumbled on it from something that Dr. John sent out.
Yeah, absolutely. So there are like multiple packages, and data science packages is really good to learn. What I tried to do today is to just like try to go through the basic packages like pandas and matplotlib, but you know, like there are other packages that are more powerful but less common. Like not many people would use them, and sometimes the support would like not be there. So I tend to use like pandas all the time for my data manipulation. But yeah, like there are multiple packages that you can use, and that can actually do the job much easier. If you're like familiar with tidyverse, I think like data science project, like the package actually is like mimics that. So it's a great package to learn. Yeah, William.
Thanks a lot.
Yeah, of course. Yeah, I mean, what I can say, the data science life cycle is kind of like a sport, and you have to practice along those steps so you need to acquire knowledge along that life cycle. So you might be able to like copy some code or like run some modeling right away. Like there's code everywhere, but you need to like slice it in terms of steps, and then learn in each step and practice and code more to become more efficient. And no one is like more efficient in all of it, but it's a learning curve, and it's practice like as you go.
So a follow-up question on that. So what is in the horizon now? Now everybody is talking about Python. I'm getting older now. If I learn Python, by the time I finish, there will be something new. Is there something in the horizon?
Yeah. So, always, right? Well, I would say not like Python is the fastest growing language. So you're probably safe for like another 2-3 years. So if you can learn Python in 2 years, you'll be good. But there is like Julia, I think, which is like does data science much easier. And but when we think about like really changing the stack, because like lots of companies, for example, built all their data science projects using Python. So it's very difficult to train people on new languages, modify all their stack, like recode everything. So I would say, yeah, like Python for the foreseeable future is the language of data science.
And adding to that, I may also start. I remember when I was in grad school, it was C++ and especially C++ for GUI, GUI coding, and then we had Smalltalk, we had COBOL. So I think the thing is, once you see the language coming, just try and look at it, and then take things like this. take advantage of conferences like this. I think that's the, and so I'm really happy, like Dr. John set this thing up. It gives an opportunity for the minority group to also have these resources, which are available but not well advertised to the minority core. So that adding to what Anas mentioned.
Yeah, well said. Yeah. Like I mean, I've coded in C, C++. I mean, like there are like a few companies that still use C++. And if you want to do computer vision, it's actually faster using C++ than Python, because most of the OpenCV library like that you use for computer vision is written in C++. So I know I have came into contact with this company that do try to detect objects for airplanes. When an airplane is going or like landing, it just detects at the real-time objects, and all their stack is using C++. So it's really depends where you end up.
And then one last thing, just not to get this to happen. And most of the languages, I'm not really sure about Python, but R has C underneath it. So if you're doing things that are like heavy lifting, people normally develop the application in C and then make R calls to C. I'm sure Python also has that. I haven't tried that yet. So the old languages still hold, and if you know that, it's advantageous, but it's better to keep chasing around after these new ones, because that's where the money and the market is.
Yeah, correct. Yeah.
Okay, so if there are no further questions, we thank you so much, Anas, for a great presentation, and hopefully we'll get you back at another time sometime. All right, yes. So the rest of you enjoy your weekend, and then hopefully we'll see all of you in your numbers in 2 weeks.
All right, thank you, Anas.
Bye-bye.
Thank you, everyone. Appreciate it.
All right.
Bye.
Bye.